The role that 3D printing has in making these suits, especially this RoboCop suit, is it was the master tool. I mean, everything, once all the 3D assets were done and finalized, machines were just outputting part after part for about 3 weeks straight of all the main components. So what we're seeing here with this chest piece, which is the first piece that I did in-house on our Connex 500, is there's not another technology out there that we'd be able to do a piece this size. It pretty much fills up the entire build volume. Not that much detail necessarily, but large part. But then throughout the part, you have crazy amount of detail. So you have the mixture of flat surface, insane detail that we need to keep for the molding process. I don't know of any other technology out there that would have been able to satisfy this. The visor for this suit here was printed at 16 micron in a Vero material, and then from there they cast into their clear shell. We did early tests in Vero Clear, which came out great, but they wanted to go as high with a traditional process to come up with as much of a high-res look as possible. So what we did inside of that visor, as that was being cast into the ultimate final clear material, we booleaned out a channel, and what you actually see in this prototype right here is a Vero Clear arched piece of material right off of the printer that's pushed together with red running through of it. So there is, in the Hero helmet, a Vero Clear final right off of the printer RP part.
Very cool.
Yeah, so that red strip is all Vero Clear. Another example here with the exosuit is, so everyone asks here like, oh, what was 3D printed? So obviously we 3D printed out the master bucks for the visors, the helmets, a lot of the different clips that you see here that get cast and run in different materials. But a great thing that no one knows about is that early on we needed to do these functioning fingers that you see here with springs. And they wanted to have all these tests of different versions of the exo fingers that are all done in 3 parts of articulation. So when a finger bent, the springs would bend. So we actually did some in-house techniques and ran these in multi-material properties. We mixed and matched 2 different materials to come up with a stage of 3 different digital materials with overmolding, with booleans in of the channels, so we could put springs inside and actually bring these to life in early prototypes in multi-materials, showing what the end product would be. These machines are so great to have next to the creators that you don't need 5 people to run them and in this crazy environment to run them. Our machines are right there in our bullpens. Our artists are part of it. Those machines are outputting, those artists are feeding those machines. So when you're around something all the time, even if you're not the one pushing the button, you're learning from it. You're seeing what worked, what didn't work firsthand, and that's invaluable.
And you have the capability of changing your design slightly.
If we see something's not working, we can make another iteration, go to another open printer, and be printing 2 simultaneous tests within an hour to see a result when we get back from lunch. It doesn't get better than that.